Hey everyone, this is Mohammed Nadeem and welcome to my YouTube channel. Today we will discuss about alternating current generator. This is the construction of alternating current generator. On the left side we have the north pole of the permanent magnet and the right side we have the south pole of the permanent magnet. Between these two poles of the permanent magnet we have the coil and this coil is in motion. So when the coil is in motion, the change in magnetic flux will be occur. According to Faraday law of electromagnetic induction, the change in magnetic flux will induce the current in the conductor of this coil, and the direction of the current in the conductor of this coil is given by the Fleming right hand rule. So here this term represents the direction of the coil. So this side of the coil is moving upward. So here this term represents the direction of this side of the coil, and the finger represent the direction of external magnetic field, which is from the left to right, and here this middle finger represent the direction of the current, which is from bottom to top in this side of the coil. And similarly, according to the Fleming right hand rule, the direction of the current in this side of the coil is from the top to bottom, and with each terminal of this coil, the one slip ring will be attached. So this slip ring is taking the current from the terminal of the coil, and that current is further passed to this carbon brush. Okay, so similarly we have this slip ring which is attached with the other terminal of the coil, and the current from this slip will be further proceed towards this carbon brush. Okay, so this the current from each carbon brush will be delivered to our home, and that we will use for different home appliances. Okay, so here we have that same scenario. On the left side we have the north pole of the permanent magnet, on the right side we have the south pole of the permanent magnet. Between these two poles of the permanent magnet we have this coil. This is actually a single coil, but we take the snapshot of this coil at different position. So this is the first position, this is the second and third, fourth, and this is the last position. Okay, so in this position the coil is present actually in this form. Okay, in vertical form, and this upper side of the coil will have some area. In this case, the area is the direction of the area is perpendicular to the area. Okay, so here the direction of this area is outward from the screen. Okay, and the direction of external magnetic field is from left to right. So here the angle theta is equal to 90 degree is present. Okay, so this is the first position, this is the second position, this is the third, and this is the fourth, and this is the last one, which is called the fifth position. So in the first position the angle is 90. So in this case, from this side of the coil the magnetic flux is given by this. Okay, so for the first position, magnetic flux is given by phi of B is equal to B A cos of theta. So in this case, in the first position, the theta was 90. So this flux is become BA cos of 90, which is equal to 0. And according to Faraday law of electromagnetic induction, the flux, the change in flux with time is directly proportional to the induced EMF. So in this case, when the flux is 0, the EMF will also become 0. In this case, the EMF is equal to 0. Now, in the second position of the coil, now the coil is present horizontally. Okay, so on this side of the coil we will have some area, and the direction of the area from this side of the coil is from left to right, and similarly the direction of external magnetic field is also from left to right. So here the angle theta is equal to 0 is present. So the magnetic flux at this position, in this second position, is given by this. Okay, magnetic flux is given by phi is equal to ba cos theta. In this case, the theta is equal to 0. So uh, phi is equal to ba cos of 0, and cos of 0 is equal to 1. So this become ba. And here the flux is maximum. So therefore, the EMF will be also present. EMF will be present in this case. Okay, it will have some maximum value. And in third position, the coil is again vertically. Okay, so on this side of the coil, here will be some area, and the direction of the area of this side of the coil is outward from the screen, and the direction of external magnetic field is from left to right, okay, and here in this case the angle theta will be 90. So for the third position, the angle theta is 90. The magnetic flux in the third position is given by the same formula, which is phi is equal to ba cos of theta. And in this case, the angle was 90, so the phi become ba cos of 90. Okay, cos 90 is equal to 0. So if the flux is 0, then the EMF in this case will also become 0. Now for the fourth position of for the fourth position, so in the fourth position, the coil is again horizontal. Okay, so the coil is horizontal, and the left on this side of the coil, okay, we'll have some area, and the direction of the area and this side of the coil is from left to right, and here the direction of external magnetic field is also from left to right. So in this case, the angle theta is equal to 0. So for the fourth position, the magnetic flux is given by this. The flux is equal to ba cos of theta. So in this case, the angle is 0. So uh, flux is equal to ba cos of 0. Okay, so this flux is now in this case is maximum, which is ba. Cos of 0 is equal to 1, so it become ba. So here the EMF will be also maximum. Okay, so in this case the EMF will be present. Okay, it will not 0. Now in the last position, the coil again become vertical. Okay, so on this side of the coil, we will have some area, and the direction of that area is outward from the screen, and the direction of external magnetic field is from left to right. So here the angle theta is equal to 90 will be present. So in this position 5, the magnetic flux is fifth position. The magnetic flux is given by this. So phi is equal to ba cos of theta. In this case, the theta is ba cos of 90. Now in this case, the theta become 90. So cos 90 is equal to 0. So again the flux become 0. So the EMF, the induced EMF in this case will be 0. Okay. EMF is equal to 0. Now, in this case, in the first position, the EMF is 0. Okay, so this is the graph for the EMF, and the y-axis we have the induced voltage, mean the EMF across the coil. Okay, this is the positive value of the EMF, and this is the negative value of the EMF. Okay, so this is actually the a different snapshot. Okay, in this first position we will have the EMF is equal to 0. So here the EMF is 0. Okay, and in this second position the EMF is maximum. So here the EMF is maximum, the induced EMF is maximum. And in this case, the in third position, the EMF again becomes 0. Okay, and in fourth position, the EMF become maximum, but in the negative side. Okay, and in the last position, the EMF again become 0. So it will form such a like shape. Okay, so it forms the sinusoidal wave. Okay, if we change the position of this coil per degree, okay, it will give us the data points here. Okay, so for per degree it will give us this a data point. Okay, so if we take 90 steps, okay, if we take 90 degrees, then it will reach here to this 90 degrees. So if we join these all points, it will give us this curve like shape. So the similar case is present in these all. Okay, now the question is that arise here is that why the EMF is positive here and the EMF is negative here, which is given by the Fleming right hand rule. So according to the Fleming right hand rule, and this side of the coil, the direction of the current is from bottom to top. Okay, and similarly on this side of the coil, the direction of the current is from top to bottom, it which is opposite to this side. So therefore, and this positive cycle, the this actually represent this side of the coil, and this negative negative side of this cycle represent this side of the coil. So therefore here the EMF or the current is in opposite direction. So therefore here the EMF is positive and here the EMF is negative. Okay, so the in the AC generator, such like phenomena is present, and it induce the current. Okay, so here according to Faraday law of electromagnetic induction, according to Faraday law of electromagnetic induction, the EMF induced is given by this. The EMF is equal to minus n del phi by del t. Okay, so here we'll have to put the value of the phi n del, instead of this phi we will put b a cos of theta divided by del t. Okay, so here this n is the number of the turns in this coil. A is the area of the coil, which is constant, and B is the external magnetic field, which is also the constant. So here we can write this equation as the EMF is equal to minus in B A del cos of theta divided by del t. Now we know the expression for the linear velocity v is equal to the distance covered per unit time. Okay, so the angular velocity here is given by angular velocity is represented by omega, which is equal to in for this distance. This is the angular displacement theta divided by t. So from here, theta is equal to omega t. Okay. So this equation 1 become this. So here equation 1 implies that EMF is equal to minus NB a del cos of, instead of this theta we will put omega t divided by del t. Here the differentiation of this cos theta will give us the sin theta. So EMF is equal to minus NBA, and here the differentiation of this cos theta is which is given by minus, okay, minus sine omega t and del omega t divided by del t. Okay, so on further simplification it become this EMF is equal to minus n. So this minus and this minus become positive. So NB a sine omega t, and this del t and del t will be cancelled and it become omega. Okay, so on further simplification it become nba omega sine omega t. We put this omega before here from this sine omega t. Okay, it give us this, and let's call this as equation 2. This is equation 2. Now for the maximum electromotive force, the sine omega t will become 1. Okay, so if it become 1, the equation 2, in this case the equation 2 become electromotive force is equal to n b a omega. Okay, and this sine omega t become 1. Okay, so this is actually the E maximum. So this is equation 3. Now put equation 3 in equation. Put equation 3 in equation 2. Equation 2 become electromotive force is equal to NBA. So instead of NBA omega, we will put E the electromotive force maximum. Okay, so equal to sine omega t. So here this is the equation 4, and we know that the time period is actually the time taken to complete one rotation. So time period is equal to time taken to complete one rotation, which is equal to 2 pi by omega, and frequency is the number of turns per second. okay, and which is inversely proportional. So frequency is equal to 1 over t. The reciprocal of the time period is the frequency. So here 1 divided by the value of the time period is 2 pi by omega, okay, so it become omega by 2 pi. So from this relation, the omega is equal to 2 pi f. So if we put the value of omega here is 2 pi f, then equation 4 become this. Equation 4, here equation 4 implies that the electromotive force is equal to electromotive force maximum, and sine, instead of this omega we will put 2 pi f, 2 pi f, okay, and this is t, this is t.